Hi boys and girls, it's Mr. Pancholi here. Welcome to your first physics lesson, and hope you're keeping well. Hope everything's been okay with you guys. Hope you had a chance to enjoy the sun as well as get some work done. Right, let's make a start then. So we'll be looking at atomic structure today, and by the end of today's lesson you will know what an element is. You'll know the names and properties of the three subatomic particles. You'll be able to describe the structure and the proportion of the atomic nucleus, and you'll be able to describe what an isotope is. Okay, before we go any further, I'd like you to have a go. Have a go at drawing what you think an atom looks like. Pause the video and we'll go through the answers in the next slides. Next, write out how you would describe the properties of each subatomic particle that you may have drawn in your diagram. Again, pause the video and we'll go through the answers in the next few slides. Right. So now, hopefully, you'll be able to check your answers against what I've got on the slide. So here's my diagram of an atom. First we have an electron. You'll notice the electrons are in shells orbiting on the outside of the atom. We then have neutrons. They are in the middle, in the nucleus of the atom. And we have protons. They're also in the nucleus center of the atom. And this area here is called the nucleus. It's the center of the atom. The nucleus is where most of the mass of the atom is concentrated. Electrons are very tiny and they have a very, very small mass. Their mass is almost zero. It's actually 1/2000. So you probably need 2000 electrons to make up the mass of the other subatomic particle, neutron or proton. The neutron has a mass relative to the other two of 1. And the proton has a similar relative mass, also 1. Have a go at pausing the video and copying and completing this table with the information that you've just learned. Pause the video now. So this is what you should have got. Protons have a charge of +1. They are positive. Relative mass is also 1. Neutrons are 0 charged. They're neutral. Neutron, neutral, and 0, no charge. They also have a relative mass of 1. What that means is, relative to the protons and relative to the electrons, their mass is 1. Electrons are the negative particle, subatomic particle. They were the ones that were on the orbit in the shells around the outside. And they are so tiny, and like I said, you need 2000 electrons to get the same relative mass as 1 proton or 1 neutron. Protons are positive. Easy way to remember it. P for proton, P for positive. Neutron, neutral. And electron, no quite simple way of doing it, but hopefully if you know the other two, you'll know the electrons are the negative ones. In any atom, we should know that the number of protons, remember the protons are positive, and the number of electrons, remember electrons are negative, are the same. What that means is, if I have 5 protons, I must have 5 electrons in the outer shell. If I have 12 protons in the nucleus, there must be 12 electrons in the outer shell. The positive and the negative charge Positive from the protons, negative from the electrons, cancel each other out in an atom. This means that each and every atom is neutral. They have zero charge. The positive and negative have cancelled each other out. But sometimes atoms are able to lose or gain electrons from their outer shells. Important note here is that out of the 3 subatomic particles in an atom, only the electrons can be lost or gained. The protons and the neutrons remain the same in most atoms. So if an atom loses or gains electrons from its outer shell, this now means that there might be more protons than there are electrons, or there might be more electrons than there are protons. Either way, the positive and negative charges are now unequal. This now means the atom has a charge. It's no longer neutral, zero charge. It now has a charge. Charged atoms are called ions. That's the name for a charged atom. So here we have Na on the periodic table, sodium. You'll notice next to the Na there are 2 numbers. The Na references the element name. Sodium is an element. Capital letter at the beginning followed by a small letter means it's one element. If I had, not in this scenario, but if somewhere written there were 2 capital letters, there would be 2 separate elements. So in this case, we've got sodium. I know that by looking at the periodic table. Na is the element name, followed by the mass number. Now, a lot of students say the top number and bottom number. To be honest, that's not the correct way of saying it, because in some periodic tables they're swapped around. So it's not top and bottom, it's the large and the small number. And an easy way to remember it is the mass number is the massive number. Out of the 2, it's the biggest number, it's the massive number. It's called the mass number. And the mass number gives you information about the subatomic particles in that element. In this case, it tells you the number of protons in the nucleus plus the number of neutrons in the nucleus. So 23 is the sum of the protons and neutrons in sodium. 11, the smaller number, not the bottom, but the smaller number, is called the atomic number. And this tells you just the number of protons. So you might be able to jump ahead a bit here and think to yourself, if the 23 is the sum of the protons and neutrons, and 11 is the number of protons, using a bit of maths, you'll be able to work out the number of neutrons if you had this information. Also bear in mind, and a very important note here, that the atomic number tells you the number of protons only. It does not tell you the number of electrons. You just have to say, and if this comes up in an exam, that you know the number of protons, so you can work out there must be the same number of electrons. You should not, in an exam or in science in general, you should not say that the atomic number tells you the number of electrons. That's not correct. It's the number of, atomic number tells you the number of protons, and because you know that they balance out, this is also the number of electrons. Just something to bear in mind there. So have a review of this, pause the video, and copy and complete this table. I've done the first one for you, so we looked at sodium in this example here. So I've completed the table. The mass number is the massive number, so I've got 23. The atomic number is a smaller number, tells you the number of protons. So the next one, number of protons, is the atomic number, it's 11. The number of electrons must be the same as the number of protons, also 11. And with a bit of maths, I know that the number of neutrons must be the mass number, take away the atomic number. That gives me 12. Pause the video right now and have a go for yourselves at completing the rest of this table. Okay, so this is what you should have got. I'm not going to go through all of it. You can pause it and check your answers against these to make sure they're correct. Obviously, if you've made any mistakes, please do correct them. I'd like you to have the correct notes in front of you. And let's move on. Size of the nucleus. Now, I know that you've come across the word nucleus also in biology. So that's the center of the cell, the control point of the cell. But in this scenario, in physics and in chemistry, nucleus refers to the center of the atom. It's not a living thing, the atom. The radius, remember in maths, radius means from the center outwards to the edge. The radius of the atom's nucleus, now this is fantastic, the radius is 10,000 times smaller than the radius of the whole atom. So in proportion, the nucleus is 10,000 times smaller than the atom. The rest of the inside is just empty space. There's no air, there are no particles, it's empty space. Let's put that into context. On the screen has popped up a tiny pea. Imagine the size of a pea, about a centimeter across. So, if the pea represents the nucleus of an atom, and we were to place the pea, it would be the same as placing the pea in the center of a full-size professional football pitch. The outside of the football pitch would represent where the electrons are zooming around, and everything else in between, the nucleus and the electrons zooming around the outside, would be empty space. Most of an atom is empty space. Elements. What is an element? You may have come across this in Key Stage 3. Elements are made up of only one type of atom. They're listed on the periodic table. Atoms of any particular element always contain the same number of protons. So if I was to get gold here, or gold in America, or gold in Africa, they'd all have 79 protons. If the proton number changes, then it must be a different element. What about isotopes then? Well, isotopes are the same element, but they have different numbers of neutrons. Let's compare these three carbon. They all have 6 as their atomic number because the number of protons stays the same. But you'll notice the mass number changes. That's because each one has a different number of neutrons. This is called an isotope. Pause the video and make notes from this page. Okay. Bear in mind, if at any point you'd like to pause the video in any of the slides, you can go back and make notes wherever you need to. And on that note, have a go at the final question, pause the video, and have a go at answering this exam-style question. And here's the answers. You'll notice that B is the different element, and the answer is because it has the different number of protons. If you remember back to the previous slide, we said the number of protons determines which element we're talking about. And I've put there in brackets just a little explanation as to how we got there. Part B was asking which one are isotopes. Well, A and C must be isotopes because they both have the same number of protons, but different number of neutrons. And C, we've now deduced that the dark circle must be protons because it always equals the same number as the X, which must be electrons, that has the smallest mass, and therefore the clear circle must be neutrons with no charge. Thank you very much. If you have any questions, drop me an email, but in the meantime, we'll catch up in the next session. Thank you.